Once again, welcome, my dear friends. Session 6 on signal flow graphs, Module 2 of Control Engineering. Let us once again understand some signal flow graph examples. Understand how to get the overall transfer function or control ratio by using the Mason gain formula. Let's take another example. So in this example, they have given the block diagram. So your job is to convert the block diagram into signal flow graph diagram. So in some of the examples in exams, he asks like this also. Given the block diagram, you have to draw the signal flow graph, then to find the transfer function of overall gain using the regular procedure. Let us draw the signal flow graph by using this block diagram. You just see here, this is the input R, this is the output C. In between, this is summing point, this is G1, another summing point, G2, G3, here summing point, and this is the takeoff point, this is another takeoff point, this is another takeoff point. Okay, so here you take number of nodes. This is for one input, one for output, one node. Yes, one node will be at here, one node will be 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 here. How many nodes? 1, 2, 3, 4, 5, 6, 7, 8. Just see here, 1, 2, 3, 4, 5, 6, 7 and 8. Let us see from where to when what is flowing here. Just see from R to this takeoff point, nothing is there. You can take unit transmittance. Again from here to here, nothing is there, unit transmittance. And from here to here, that is G1 taken here with this forward path G1. From here to here, that is G2. Again from here to here, that is G3. That is G3 here to here. And you see from here to once again this point, from here to this point, that is H2 with this sign. Again from here, from this point to here, nothing is there, that is unit. Again from here to here, that is unit transmittance. Similarly from here to once again this point, H1 is there. From here to this point, H1 is there minus. Again from here to here, this is plus, that is same H1. Okay. Again from finally this forward path, from this takeoff point to directly from here to here, this one, it is a G4. Okay. So here once again, so we have converted the block diagram to the signal flow graph diagram. So once again here it will be time consuming. So carefully redraw the signal flow diagram, or you can call the modified block diagram to signal flow graph with all the transmittance with the arrow mark. Carefully you have to redraw. So next once again the usual procedure. So here the signal flow graph of the above block diagram is shown here below. So there are, identify the number of forward path. How many number of forward path here? Yes, there are 2 forward paths. What are those? Just see here R2, the straight one forward path. Another one is from here to here to directed to the bypass, directed to the output. Okay. So what is the path gain of both the twos? That is P1, that is G1, G2, G3. That is here G1, G2, G3, and the next one is only, what is that? The G4, directly here to here, that is G4. So how many number of loops here once again? Here this is one loop, another here, another loop is here, yes, another loop is here, and another loop is here. There are 3 loops. So what are the path gain of that one? So here G3 and H1, that is shown here. It should be G3. Sorry, G2 only, correct, G2 only, G2 and H1 with minus sign, minus G2 H1. Next G1 G2 and H1, G1 G2, that is H1, that is shown here, G1 G2 H1. Next one is yes, from here to here and here, that is G2 G3 minus S H2, that is minus G2 G1 G2 G3 H2. This is another loop. So there are two loops, P11 shown here, P21 and P, this is 31, like that. So no loops are non-touching, all are touching each other because this is the node. These two nodes are common between all the S loops, hence there is no any non-touching loops. So hence no loops are said to be touching each other. Okay. So once again here there are no non-touching loops. So go further, that is you have to find the S delta 1 and delta 2. First you find the delta value, that is delta equal to 1 minus sum of individual loop gain, that is L1, L2, L3, that is minus, you have to substitute this value here, this value here and this value here. Okay. So one more thing here, what is that? So here that value of delta, because the loops are touch, no nodes are common here, delta 1 is minus 1 and delta 1 is 1, and since no loops are touch with each other, therefore delta 2 is also yes. For this forward path G4, that is the value of delta, that is this loop is non-touching, that is G2, G3 and H1. For this forward path this is non-touching, that you have to take. Delta 2 is 1 minus yes, 1 minus G2 G3 and minus H2, that is minus of minus 1 plus G2 G3 and H2, that you have to add here. Okay. So finally the Mason gain formula, what is that? So hence here two forward path, P1 delta 1, P2 delta 2 by delta, substitute all these values, already we have seen, get the overall transfer function. Coming to the another example, you just see here, this is little bit complicated as compared to previous examples. What is that? This is input, one summing point, another summing point, another summing point, one takeoff point, another takeoff point, one summing point, another takeoff point, another takeoff point, and output. So how many summing point here? 1, 2, 3 and 4. How many takeoff points? Yes, 1, 2, 3 and 4. So here 4 summing points are there, 4 takeoff points are there. Let us once again redraw the block diagram to the signal flow graph diagram. So as I told earlier, for input you give one node, for output another node. So how many nodes you may expect? This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 nodes. Just see here, 1, 2, 3, 4, 5, 6, 7. Only 7 nodes they have taken. No problem, because in between here nothing is there. They have taken unit transmittance. Okay. So here from input to the here nothing is there, 1. From here nothing is there, 1. From here to here, that is G1, that is taken here. This is 1 and 2, this is G1, taken G1 here, again G2, from here to here G2, here to here G2, from here to here that is G3, again from this one from above that is G4. So from here to here that is G4, and here from here to here that is H2, here to here that is H2, again from here to here that is minus 1. Nothing is there means that is minus 1. Okay, once again find out the number of forward path. How many number of forward path here? That is, this is straight forward path. So here once again, after drawing the equivalent, yes, and identify number of forward path. There are two forward paths are there. What are that? This is straight forward path. Another one is from here to here. So from here to here. That is straight forward path, and from here to here, two forward path. What is the path again? G1, G2, G3, and this is G1 directly to the G4. This is G1 and directly G4. Two forward paths are there. Only two forward path. And five. How many feedback loops? There are 5 feedback loops. Okay. This is 1. This is 2. This is 3. Once again from here to here that is 4, and once again from here to here that is another loop. So like it below. So this is another loop below. What is that? I will show here. This is also one more loop here. This is one loop, and this is last one loop from here, and once again you can take here to here. This is one loop. This is straight forward one loop. If you are taking off this one another loop, so hence there are how many loops? There are 5 loops. That is shown here. That is P1, G1, G2, H1. That is G1, G2, H1. That is G2, G3, H2, G2, G3, H2. This is G2, G3. Directly only this is one loop. Once again G1, G2, G3. What is that one? G1, G2, G3 with minus sign. This is one loop. Then G2, G4, H2. That is G4 and H2. Only this one. This is one loop. This is one loop. G4, H4. What is the fifth one? G1 and G4. So directly here, here to here. That is another loop. And there are 5 loops. So any non-touching loops here? All the loops are touching each other. There is no any common node between them. Hence all the loops are said to be touching each other. So hence what is that? There are no non-touching loops. Hence value of delta is 1 minus sum of individual loop gain L1, L2, L3, L4, L5. Just go on adding here. 1 minus of minus plus. Yes, plus into minus minus, plus into minus minus, plus into minus minus. The last one is minus into minus, that is plus. So this is the value of S. This is the value of delta. It's coming to the S. Delta 1 and delta 2 as the feedback loop touches 2 forward paths. Hence delta 1 delta 2 equal to 1. There is no any loops touching this forward path. These 2 forward paths, everything is touching. Hence the minimum value of delta is 1. So once again using the control ratio, what is that? Once again you have to see the control ratio. There are only 2 forward paths, P1 delta 1, P2 delta 2 divided by delta. Similarly substitute the value of delta, P1 delta 1, P2 delta 2, and delta value. You will get this transfer function or overall transfer function, or you can call control ratio. So by these examples, what you are going to learn here by using signal flow graph, it is easier as compared to block diagram, but only tough thing is that you have to identify the number of forward path. If you went wrong in finding a one forward path, if missing, you will get the wrong answer. So both the block diagram as well as signal flow graph have their own significance. So in the block diagram, only tedious thing, you have to redraw the modified block diagram and go ahead using those block diagram reduction methods. But here in case of signal flow graph, you have to identify the number of forward path and even number of loops. If any one loop is missing, you will get the wrong answer. And once again, after this, you have to identify the pair of non-touching loops. If any pair of non-touching loops is missing, you will get the wrong answer. That is what the difference of what is that? The block diagram and signal flow graph diagram. You will get both the example, you will get the same answer. Only thing, you have to carefully solve the example. So with this, I will conclude my session. Thank you.